I can take notes today.
Sounds good. Thank you. Do we have any new faces? I don't think so. Release planning and updates.
I guess on the life cycle side, yesterday in our sub-team sync, we talked about shipping a patch release just to get in a fix for, we noticed that we were logging sensitive data that we shouldn't be doing. So we want to get a patch out for that. And then we'll probably be cutting a release candidate for lifecycle 012 in the next couple of weeks.
Any updates on the platform side? Or I guess we don't have any here.
The 020 went out yesterday, I think.
Yeah, I saw the thing. All right. Any updates from distribution or learning teams?
Nothing from distribution.
Nothing I can recall from learning either. We do have a new contribution page on the website. So I know people in the past have asked like the current contribution date was hidden in the community repository. So we moved it to the website. I think one of our, I don't know, someone who's new to the project contributed the initial stuff, then Javier formatted it to make it look good. But it's something people have been asking for a while. That's it.
Maybe the last update to note is that we're close to being, oh, I turned pink. I'll fix that in a second. We're close to being finished with platform API 07 in the spec and should probably get that release out in the next week.
Awesome. I think that's all the updates. So we'll go right into Anthony's RFC on State Field.
Yes, I just wanted to highlight a new RFC in case y'all are too busy and might have missed it. It's pretty straightforward. It's in the meta section of every RFC, I want to put a state identifier and formally introduce a new state for an RFC being on hold. I think we have a couple RFCs recently that we don't want new contributions at this present moment until stuff has been resolved. So that's the sort of the twofold proposal here. One is add that little section and then add a new state for on hold. You can click for more details. If you want to ping somebody, you can ping me or actually Emily if you want more details. That's about it. Take a look.
Looks awesome. I think we can introduce more states in the future too. So we can kind of clear up that, make it easier for people to look back at those existing RFCs.
Oh, sorry, I keep forgetting this. State or status, I honestly don't mind at all. I was flipping between the two when I was writing the two. So I have absolutely no strong feelings about what word.
Yeah, that's hard. Maybe I lean more towards status, but I don't think I have an opinion. Any other thoughts about this?
The only comment I had was currently it puts all of the states in like a bar separated list. That might get out of hand once we have more states. So, and it also might be confusing if people say see multiple ones in there and the one that's currently in is bolded out. So maybe just put one thing there and move the definition of the states in the template as a comment or something.
We could even put draft in the template, and then in our merge RFC script, switch it to accepted. And then any other status change or state change could be a PR explicitly.
These are all very good comments. I would appreciate it if you put it in writing though, as opposed to right here. Thank you.
All right, any other comments on add state field? Cool. We will move on to bomb format.
So I just wanted to share a couple of updates on this RFC. Been speaking with Steven, and I've also been observing what's happening with like the new Gates releases and like other things in the CNCF ecosystem, how they're adopting SBOM. At least within like Linux Foundation projects, it seems to be largely tipped towards SPDX, which means that although it may be easier for us to adopt Cyclone DX now, and it also suits us well, we might alienate ourselves from the rest of the CNCF community. I don't know what's going to happen there, because the last time we presented to the Secure Supply Chain Working Group, right after that, I think there was some conversation on SBOMs, and it seems like there's a lack of consensus on CNCF as a whole on which bomb format they're leaning towards, and they're also trying to figure that out at the same time. So Dan, who works on Sigstore, has been working on a proposal for attaching bill of materials to images and also signing them. And I've been working with him to figure out how to incorporate our use cases into that as well. So currently I've updated the RFC with a couple of suggestions, which I don't know how others might react to that, but here it is. So I've updated it to include SPDX alongside Cyclone DX as a SBOM storage format, because those are the two formats that Sigstore currently supports. And I've also given up on trying to merge it in the lifecycle itself. So if you look at the current proposal on the Sigstore site, what they have is this SBOM manifest that can contain different SBOMs in separate layers. And these SBOMs can point to a target object, and each SBOM can describe one or more layers. So what this means is, let's say we have multiple different Buildpacks, each providing different output formats. Like let's say Buildpack A provides SPDX, Buildpack 2 provides Cyclone DX. You could still upload all of them individually and point to the layer that they generated, at least within the Buildpack. Like, since they control the layers and they control the bomb format, there's a very easy one-to-one mapping. In terms of a bill of materials that describes the entire target object, I've sort of taken some inspiration from Steven's Gen Packages binary and proposed a merge bomb binary. So the project would provide a default one where the input to the merge bomb binary is this layer directory structure, which contains the bill of materials produced by each of the build packs, and output file locations for the build and launch bomb, which is merged. So the merged bomb binary will take these three things in as input. It can read from this directory and output to the build and launch bomb. The project can provide a reference implementation for this for merging Cyclone DX stuff. But let's say Paketo has its own set of fields defined in the previous BOM format, and it wants to convert and map it to either Cyclone DX or SPDX using its own mapping. It could override this merge BOM binary with the one that project supports, and it could map things like it currently supports like source shars or whatever to appropriate fields either in Cyclone DX or SPDX, and the lifecycle would just use that to merge it. If such a binary is not provided, the lifecycle would just skip merging it, and it will just upload the individual SBOMs, which will point to the appropriate layers. And that's pretty much it. These SBOMs can be different formats. And I have also been, I've also left some other comments on how we could also incorporate build and launch forms. So that may be one way of storing SBOMs with different formats, trying to merge them into a singular format, accommodating for future versions or types of SBOMs while getting rid of this dependency from the lifecycle itself. And the project could provide a default merge BOM, which Pack could include during create builder or something for the formats we do support. So that it's seamless for like Cyclone DX and our typical backwards compatibility compat use cases. But if someone wants to override it to output their own format, or if you want to use a different format in the future, they can do that. So it keeps very little SBOM knowledge in the lifecycle itself while still supporting all these different BOM formats, and also reconciling with the Sigstore proposed BOM format. But those were the changes I made to this RFC for now.
I think I have two comments. One is, so you mentioned that having the separate layers like in the Sigstore format. I think using the Sigstore format is a really good idea. Like I'd be really happy if we just dropped everything we talked about for SBOM, like labels or, a label that points to an image, a layer instead of the whatever, and just did exactly what they did upstream and said, yep, we're just going to use cosine to do labeling. I think that would, why make another standard, right? Totally on board with that. But the way they let you do an SBOM for separate layers, and my interpretation of that is more like, because they're separate objects, you might be using OCI artifacts, and they might be separate pieces of software or individual things, like because there's upstream, they're not thinking about the semantics of the SBOM. It makes a lot of sense, right? In our case, I'm not pushing back hard against this, but it feels like the ask from users is like an SBOM for their app that includes all the parts of their app, right? That may, use features of the SBOM format to show that the parts have relationships to each other. Like separate SBOMs for each layer in the application don't, it's further away from the semantics sort of the application. So I think I'd advocate more for one, although it's not a strong preference. We'd still want to label each of the entries with the thing. And the other thing is very related to that with the merge BOM binary. So like a reason we put like gen packages on the base image, or like we have stack provided binaries, is to form a contract with the stack and the API where the stack could be really different. We need some kind of translation layer that's provided by the stack author. In this case, the merge BOM binary would be doing something the lifecycle, but like it's generic, right? The lifecycle supports two formats. We're converting, we're merging groups of two formats together in a way that should be as consistent as possible. So I don't see as strong a reason to have that, binary not be part of the lifecycle process.
The main reason I didn't keep it as a part of the lifecycle was backwards compatibility. So since there's a few fields where we have a clear mapping between Cyclone DX and SPDX, but beyond that, there's no consensus in what field maps to what. So as a Buildpack author, if you're or as a project, for example, Paketo has a BOM format they've standardized on, which is from like the previous BOM format that we supported. And they now want to map those fields either to SPDX or Cyclone DX. If we don't provide such an extension, they would never be able to do that. So if we hard code, like we obviously can't hard code project specific values in conversion formats in the lifecycle itself. I totally get that the lifecycle could support Cyclone DX and SPDX and convert between the common fields. And maybe we can provide a default binary for that. But like if the operator or whoever created the builder wants to enhance it with more information, they would have no way of doing that. And this goes back to like introducing more hooks in the lifecycle. I know like we sort of assume lifecycle as the unified mediator between all of these things, but it also prevents like extensions like these, which would be useful. So it's like a sane default with like we can provide a sane default merge BOM implementation, but if some project wants to override it or wants to support some other format, they would still be able to do that. We could still claim to support certain formats as first-class formats, but we would not be preventing other projects from adopting newer formats.
What happens if you use the Cyclone DX to SPDX? There's a Cyclone DX to SPDX converter, right? Is there data loss there in that direction?
Yes.
Because SPDX doesn't have like a generic things field. I forget what it's called. Cyclone DX. If you go, what about? I know there aren't tools to convert from SPDX to Cyclone, but could you take all the SPDX fields that aren't? Because there's a way to do this with that, where data loses, some specificity in the fields that's in, but it doesn't actually get lost as it gets converted across, and it gets converted across in a way that's, very regular for the project.
So there's also data loss rates. For example, Cyclone DX only supports a single CPE field, for example. SPDX supports multiple of them, like because according to Cyclone DX, there's only one true CPE field, but according to SPDX, you can have multiple, like approximately accurate CPE fields, and then if you convert one to the other, you lose the other approximations, for example, or there are like some annotation comments or like file specific comments or whatever in SPDX that you can't convert to Cyclone DX ever.
Nat,
Yeah.
sorry. We're trying to stick to the schedule, so I wonder if this was a good introduction to the changes, and maybe we could, circle back on a longer discussion here in office hours and go on to the next topic, because I feel like there's enough complexity here that we could fill up all the time.
Sounds good. We got started about 10 minutes from the middle of the, because we started 5 minutes late, and then there was another 5 minutes of updates and stuff. So I think we're not too far off track at times, but I think it makes sense to move on.
Sorry.
No worries. So, sorry, find out what's the next RFC on the list. Sam, we should keep chatting. I think we're close, but it's definitely still some things to figure out. Read-only layers.
I think so. Something we discussed in the like in the RFC roundup in the core team sync yesterday was this RFC. I added one other alternative here where, so currently this RFC sort of exports the layers beforehand, but if some other build pack modifies it, it doesn't actually warn that build pack that any modification is happening, or that they may be making changes which may not end up in the final image. So the other alternative that I was thinking of is like, one alternative is that the lifecycle could change the user randomly between each build pack step and restore it at the very end. The other alternative was that the build pack itself could specify a UID and GID in its build pack toml for the user it wants to run as. And the lifecycle will just run that specific build pack with that user ID. So since the entire creation generation process is as a separate user, it avoids it avoids schmodding the layers later on or whatever. And that way, it sort of also follows the Dockerfile paradigm, where if you want to do operations as a certain user and have certain files owned by a certain user, you can switch the user in the middle and then go back. So if the UID or GID is not specified, it uses the default build UID and GID. If it is, it just uses the one that the build pack provides. But that was the alternative. The initial proposal still looks the same. I addressed a few comments from Emily and added examples on what the output would look like if we went with the original proposal.
I think the big change if we did that would be that now the builder phase has to run as root, which we've explicitly tried to make possible to run it as a normal user, right? I do like any solution that still lets us sort of kick out the layerizing into export, because although I'm open to doing it for the for all the reasons stated in the RFC, I have some fears that there'll be moments where Builder would be hanging between build packs trying to finish layerizing. Like, even if we do everything under the sun to make it as parallelizable as possible, I think there still could be moments where it's making the build phase longer, and that would create an impression of a longer build, even if it's, you know, just time that you have to spend in the export anyways. And I'm not totally opposed to running lifecycle phases as root, as long as we don't run build packs as root. But I know that last time we had this conversation, Stephen had some concerns there.
I think I definitely prefer not to elevate builder privilege. I think I'm more concerned about the API where all the build packs run as a user that the build packs specify, because it either implies a really strong contract with a stack, right? Or an interface that like, you know, build packs would pick large random numbers and hope they don't conflict with each other and hope they don't conflict with users on the stack, that they suddenly, you know, if they did, it would suddenly give them ability to write to the base image, which, you know, that seems like there may be a couple problems there.
Yeah, I would sort of want us to run them as random users, but all in the same group. And then we can set a strong convention that if you, what's nice about this is that then by default, nothing can modify anything it's not supposed to, unless the build pack goes out of its way to make the things it's creating group writable, which I think is like the convention we want to have for allowing the app to modify things, so it might all fit together nicely.
I worry about even if they all run as random UIDs, you know, then your file system is going to have like all these different layers, and the UID on each layer is a different random large user ID. I'd have to think about the implications of that. That seems
What if rather than the build pack specifying the user ID, the stack could that run this build pack is this user ID?
what if you have like 20 build packs? How's is the stack going to create users for each build pack? I shouldn't modify the base image. Probably, I guess it could sort of.
It doesn't have to create users, it just has to set random UIDs, right?
I don't think we want the stack to have to know which build packs are going to run though.
I'm not saying we definitely shouldn't do it. I feel like I have to think more about what this. But when you export the image in the end, are you imagining that the user IDs would be preserved at runtime, or would you like flatten them all to the same user?
Sorry.
When you export the image at the end, would you flatten all the user IDs to the same user, or would you keep them as different users?
Keep them as different users. I mean, that was. Oh no.
Same trouble. Give me a second. Emily, you said you were worried about the previous read-only layer implementation with the, even if we create the layers in parallel.
Yeah, not worried enough not to do it. But worried enough that if there was an alternative, I would be excited about that.
Yeah, that makes sense.
I was wondering, like, maybe we just want to, like, could we in a much faster way, so we're not calculating checksums and stuff like that, just have a very fast parallel process that goes and checks the mod times on all the files and just make sure nothing was changed. Like, yes, a subsequent build pack could change something and change the mod time, but like at that point, you're on your own.
Interesting. And then just warn
Or
something.
Warn or fail. Maybe just warn. It's like people are already doing this now. So it wouldn't, it at least wouldn't break people, which I know is another concern, that this would happen with build packs that exist now, but it would help people know that you're violating the spec, and we could eventually turn it into a fail. But for now, we could just warn as a way of trying to corral everything.
It is a build tool, right? It's not like, I think sometimes we look at thing we're designing as if it were like a tightly controlled, like each part is part of a tightly controlled platform, but everything that's happening in the Buildpack API, Buildpacks can do whatever they want anyways, right? So that doesn't feel like a terrible idea. Sorry, do you want to repeat that again for Sam?
My suggestion was that instead of a parallel layerizing process, we just ran a process in between builds that checked the mod times on all the files as quickly as possible and warned if something changed. And then we don't have a hard break for people who are already doing this, but we're starting to enforce the spec here.
That wouldn't solve the problem though, right? Like, users still wouldn't have a way of preventing accidental modifications. The whole reason I had was, like, if you run something, for example, like the Python interpreter, it just has side effects if the layer is write only, where by the user that's running the interpreter, and if they have access to the place where the interpreter is. So it just creates random cache files. Then you have to go through a lot of effort to turn those off. And I'm imagining you can also have this with other things.
Are you thinking about doing runtime?
No, during build time. So let's say you install the Python interpreter, then you're installing pip packages during build time. And then it would just create Python cache files when it's running pip.
So then wouldn't it still fail to build because the mod times would change at those? Or so there'd be new files, or the modification time would change of the existing files.
Yeah, but I mean, what if there's no way to prevent such side effects unless the layer is read only or if it's export.4?
If it's read only, isn't it just going to fail? Or I guess Python will do the right thing. If
It does the right thing. If it's
I
read
guess, I
only, it
guess,
doesn't.
yeah, sorry. That makes sense. That's happened to me before.
I think we just totally get rid of cache layers and there's no problem. Because then you're not keeping it around, right? It's about the restore that's the problem. Like if you're saying you don't want to fail when people are modifying these things, the crux of the problem is that when it gets restored, there are changes that the build pack is not aware of, right? Like maybe we could add, like a dirty flag to the layer tumble to be like, this is what you said it was, but I know someone else modified it. So build pack, you're on your own here. Part of my thinking about caches that I need to write down is the end of cache layers anyways. But I feel like that's a much bigger conversation.
Natalie reminds us that we are at the 10-minute mark for this one.
Glad someone here is responsible. Is it time for everyone's favorite topic?
We'll see if it's everybody's favorite topic. A lot of really interesting ideas for read-only layers. I think we should keep digging into that. I'm not opposed to it. I know I seem skeptical of the UID thing. I'm really just want to think through the implications before we commit to something, if that makes sense. All right, we will move on to Docker files. So this one is mine. Let me share my screen. Sorry, this might take 2 seconds. Everybody see this? Cool. So this has gotten really long. We are at some 100 comments at this point. My most recent change is a small change to, I guess I'll just do an overview of the whole RFC first, in the state that it's in, because I don't know where everybody's at and thinking about it. So maybe I'll actually start over here. So the first suggested change, there's 2 RFCs and I want to talk about them together. The first change is get rid of stacks and mixins completely, and don't replace mixins with anything. Base images in Buildpack TOML, instead of a list of stacks, you have a list of target platforms. These aren't like, it supports this architecture, this OS architecture and version, this OS architecture version. These are actually things that get built when you do pack, create, build pack, or create package. So like this build one for Linux x86 for Ubuntu 18.04 and 20.04, build a separate one for Linux x86, Ubuntu 14.04 and 16.04, right? I use the same OS and architecture here to make it clear that it's different targets, but you could use this to build for ARM and for x86 and 10. Mixins are gone completely. If you want to use the SBOM to do validation, like Pack-Rebase could, if an SBOM is available, use that to tell that you're doing something stupid. It could warn, but that's not part of the spec anymore. So I left in the cyclone DXX bomb to just show that that's possible, but like that's the only semblance of mixins that's left. We just have target platforms. There's no more validation between the run images at all. If platforms, or between the build and the run image at all is what I was going to say, or what I meant to say. If platforms want to do validations, they can, but it's not part of the spec anymore. Keep it really simple.
Does that
Okay.
mean that section is completely optional?
This section?
Targets?
Oh, this section.
Yeah, targets. If it's optional for platforms to validate, then does that mean it's not a required? I haven't had a chance to read it. You may say this in here, but
Mixins are optional to validate because they don't exist anymore. Like the packaging.
oh, okay.
Packages are
I
optional.
thought I'm sorry. I thought you were talking about the target platforms.
No, the target
You said that.
platforms, yeah, definitely mandatory. But if you don't specify, they're not really mandatory, because if you don't specify any of them, then your build pack is an any stack, the equivalent to an any stack build pack. It just works. There's no buts about it, if that makes sense.
Okay.
You'll just try it no matter what. This is just for your benefit. If you don't do any, it creates one for you that's probably of your current architecture. I guess we have to pick an architecture in OS, so I should think about that. But I could assume Linux and x86 if you don't put it in there.
Right now in package TOML, there's a platform section with OS in it that is similar to this, and it defaults to Linux. So we could do something here that defaults to Linux, or we could, yeah, I think we can't just, I think when there's multiples, I'd love to make a multi-arch image, but when there's nothing, we can't make an everything image.
Yeah.
Couldn't we default it to however, like when we package and store it in as a container image or OCI image? Can't we just use the entries from there, or would that not work for Buildpacks stored as tarballs?
What do you mean use the entries from there?
Like in the config, you can specify you set OS and architecture, right?
In which config?
Um,
Oh, in the image.
Build package.
the image config.
So
The problem is the image config does not have these fields, right? They exist in the image index in a multi-arch image, but not in an individual image config.
This would be for building those artifacts, right? And so you don't know the values ahead of time. This is like when you're trying to decide what image to make, because it's in Buildpack TOML. Pack create package would use these values. Sorry.
If these are absent, then when you're running this finally and you're trying to validate this, couldn't you just use the values from there? Like if you're trying to use a build pack with a different architecture as the base image and you're trying to create a new builder, couldn't you just fail there or something?
Yes, in that case, I think you definitely use those values. This is just for when you're creating. This is when you run pack create package. When you're packaging the build pack, this defines the targets that it gets packaged for.
Okay.
This method, build pack, these values in build pack TOML, I imagine would never be used after that point, because you'd have to reach into the, you'd have to download the build pack in order to be able to do the validation. Emily made a very similar point that this metadata should get put in more places. I think it was a comment you made, like on the images, maybe even exposed to the build packs, so the build packs can tell what architecture they're targeting. That all makes sense to me.
I was just checking Docker inspect, which does have OS and Arch, but it seems like when you go read the, I'm going to just double check some things. Continue with your conversation.
Anything else on this RFC before? Maybe I should just take a look at the comments before we move on to the Dockerfile stuff on top of it.
As for the stack specifying all of these things, you said it would be labels, but I don't think you've specified which labels.
The stack specifying all these things. Like
stack specifying which OS it is and which version it is or something. Like Ubuntu 14.04, I'm assuming that would be some label or something, right?
yes, so in the RFC, I say that stacks have to have that metadata, but I don't say what the metadata looks like on the stack images, just what buildpack toml looks like. I wasn't sure if that should be a spec PR that comes later. I just said there's metadata on the stack. I could put it in here if people feel strongly we need to decide it ahead of time. I'm happy to do that.
Okay, in the OCI image config spec, it does include OS and Arch, but it does not include like OS version and the full platform specification that exists in the image index. So I think we can set useful values on images, even if we're not creating a manifest list, but we can't set all of this data. So I think we need to preserve it elsewhere so that we could access it in the case where there is no manifest list, like a daemon case.
Yeah, I'm happy to add everything as nvars or something. Or like the exclusion of that was just because I wanted to get the idea across, to, define the supports Docker file stuff afterwards. I'm not opposed to adding more metadata there for sure. I think you left similar comments that I responded to.
I think my last comment on this is about, I like the idea of removing mix-in validation. I do wonder if just to prevent really unintentional things from happening, stack images should have some sort of field that identifies like a stack ID, but not in the case we had before where it describes a whole contract that means a bunch of things, but it's more like, if Paketo team is making a Bionic stack, you put something that says like, it's this one, so that when you're trying to rebase, you normally want a newer version of the same thing. And then, so it would, a way to indicate that a new run image is a successor to a previous one, but in an arbitrary way that's not about trying to understand all of the compatibility, but just trying to understand the intention. And then it's something that you could use a force to override if you didn't want to.
Like a image ID of, not like a Docker image ID, but like a, some way of identifying the image. I think that goes well with the idea that might be useful because run images will no longer be linked to build images. Buildpacks may want to, Buildpacks have a stack ID right now. Buildpacks may want to know about what run image got selected, if that makes sense. I think I said this in a kind of similar comment, but I wonder if that could be a separate RFC for like a run image identifier that, we could enforce has to stay the same and has to get passed into the, Buildpacks as an environment variable that Buildpacks could then use, for instance, to say, well, I know the run image is a scratch image, so I'm going to, statically link everything or something like that. Really supportive of that idea too. I could put the identifier in this RFC if anybody feels strongly they want it in there. That seems reasonable.
Sorry, for clarification, that's a separate run image ID from a stack ID?
Yeah, the stack ID would go away because there's no more stacks. There would just be a run image ID that is not related to the build image that gets fed into the build process and also used to validate rebase, combining the two ideas, the one that was in the comments here with the one Emily just brought up.
I think it makes sense with how people talk about these things in the wild. Like Paketo has two stacks, full and base, that share a stack ID. People are always talking about, is it the base stack or is it the full stack? Like that's kind of how people are naturally thinking about it. It's like, this is a line of images that is produced for a purpose, and I'm getting the next one.
Yeah, agreed.
Makes sense. I think I'm comfortable with that for having an ID for the run image. I just don't want to link it to the build image anymore. And I'm not convinced that we need it for the build image necessarily, because now you could use many different run images with the build image, if that makes sense. And like,
Yeah,
I'd be
I
okay
could
with-
imagine maybe wanting a different one for the build image, because theoretically we could be rebasing builders, even though we don't. It's like a newer version of the same build image. I feel like it makes sense, even if it's not as obviously useful all the time.
Subsequent RFC for that one for sure. How about that? All right, I'd like to move on to the Docker files part. If Oh, sorry, someone else have a,
I was just trying to understand how validation realistically takes place. I think in your comment, you said like builder authors would just look at the documentation of the said build packs to find out which stacks would work with that. Could you expand your thoughts on that a little more?
that was just about packages. So it's like if your build packs require packages that aren't, usually installed in the base 1404 Ubuntu Ubuntu was a trusty image, right? Then you have to put that in your build packs documentation so people know that they, either in your build packs documentation, you have to say use this base image, or you have to say use, you get it, you have to install this package on the base image first. It would no longer be something that's part of the API.
There's no way for the platform to give you any help on selecting a base image when constructing a builder.
Well, that's the next RFC, sort of. There would be no way for a platform to realize that that a given build pack needs a specific package that's aside. Yes, that's true, unless there were a separate contract for build packs defining Perl packages, Perl list of OS packages that the platform had to know that it needed to construct ahead of time. Correct.
Rather than requiring everyone in the world to put accurate metadata everywhere, so we can do that magic, which I feel like is asking a lot. I wonder if maybe a better way to do that would be to have a build pack be able to provide hints, basically. Like if we had build image and run image IDs, a build pack could say like, here are base images that I know I work with, I was validated against. Not the only ones, like you can try to use me with something else, but that would allow more things to have defaults.
I think that makes sense. We only got 8 minutes left and we haven't talked about the Dockerfile part yet. So kind of want to move on unless people feel strongly. But I agree, we could do more to hint there. Like we're just trying to remove complexity, necessary complexity for build pack authors. Okay, so I'm going to try to go through this. I get some feedback really quickly. Basically, this introduces a new, instead of allowing build packs to install OS packages, which I think introduces a big risk in that if you, as soon as a popular build pack says I'm going to apt-get install curl or something like that, then nobody in the ecosystem who's using that build pack can use rebase anymore because it modifies the base image, right? And so instead of, for stack packs, we kind of solved this by saying, well, there's a special kind of build pack called the stack pack, and it can install OS packages, but it's separate. Instead of going that approach and trying to integrate it to the build pack API, the approach here is make it so that things you would do as a builder author or stack author to create a stack that matches a build pack, things you could always do before creating the builder can happen before the build process dynamically. And so everything described here should sort of read as like, the hooks that this introduces to install packages, you can always remove those hooks and create a more narrow builder image, and none of the build packs have to change. Everything works the same way. So it's just a way to kind of, it's like a robust mechanism for dynamically ending up with the run and build image that you could have pre-baked, right? But now can happen immediately before the build process with Dockerfile-like caching. The advantage here is that it doesn't interface with the build pack API at all. It just lets you end up with the perfect images. You sacrifice a little performance at the beginning of the build to end up with the perfectly sized, if that makes sense, runtime and build time base images that match the build packs you're selecting. But it, the build pack API doesn't change. And so the way this looks is inside of builder toml, you can specify, this isn't a final thing, this is just like an idea for what it could look like. You can specify hooks that are essentially Docker files or executables that output Docker files. You can choose which one. You can map those to specific build packs or not. If you don't map it to a build pack, the hook just always runs. The Docker file always gets applied. If you map it to a build pack, it only gets applied when that build pack is participating in bin build. The hooks are kind of in this path format. Name of hook can just be for build, just be for run, or it could be for both. A format is always Docker file, and out means it's a script that outputs a Docker file. It's not a Docker file itself. Eventually, it could be LLB JSON instead of Docker files. If we wanted to get really fancy, an example of implementing app specified Docker files. So apps could have Docker files. You could do this with a hook that just because the Docker files execute in the context of the app directory. If they're executable, the hooks execute in that context. They could read Docker files from the app directory. So this is an example of like how you could let application developers specify their own build and run Docker files. Alternatively, you could look at the app directory and automatically decide to apply different Docker files. Alternatively, say you had different you have different build packs that require operating system packages to get installed. You could put hooks on the builder that for those build packs, right? Do something like install Ruby or install Node.js. And so this, as a builder author, you can now kind of create builders. You can like quickly create the right builder before your build that's targeted for the build packs you need. And so you don't need a whole bunch of different builders for different languages or whatever. You can have one builder and you can push that process into the build process. The Docker files would be in this format where the base image is injectable because it's got a chain through an arg. There's a build ID that you can use to expire the cache. There's a gen packages binary that's kind of explained here as a way of generating an SBOM. We've talked about that in a previous working group meeting, so I won't go into too much detail there because we don't have much time left. Eventually, so I opened this other RFC for dynamic run image selection. We wouldn't have to add more complexity to do that at all. We've removed mixins. There's no more package lists and build packs at all. Instead, that could be implemented by a new format called ref that just changes the ref. And because you can map that to build packs, that gives you dynamic run image selection. If this build pack is present, use this run image. And so this kind of hook API could be used to do anything you want to end up with the right build time and runtime base image before a build happens, is the idea. But again, the big point is it's not integrated into the build pack API. There are definitely some alternatives here. So like one idea Emily had is, we could integrate this more into the build pack process. I think like by having the hooks participate in the build plan instead of feeding them build packs. I think that gets a little dicey because you have to feed the requires into the hooks and suddenly they start looking like build packs and there are a bunch of restrictions like they have to be provide only. We might want the provides to be static, but I guess they wouldn't have to be. Like it starts adding that complexity that we arrived at stack packs. But I think there's probably a line in the sand we could draw where that it kind of works right on top of the Docker file API. It does reduce a lot of the complexity, something Emily and I were talking about yesterday, to output the Docker files as instructions from the build pack instead of having the build pack execute directly or the stack pack execute directly in the context of the container. So there's maybe a middle ground option between this and stack packs, but I still feel like it adds complexity and there's probably things we haven't thought of there. Got 1 minute, go.
Sure. I think one of the risks, or are you ready to turn it over for comments?
Yeah, go for it.
Yeah, I think one of the risks may be that, or maybe the trade-offs, like with regard to build packs not being able to install their own app package or whatever, is that this may perpetuate builder-specific build packs, and that like the build pack that needs to install that needs to do a thing, whatever, like the builder has to support whatever mechanism is expected from that build pack, whether it's like build.docker file or something else, right? And I guess this is on my mind because there was a Stack Overflow question where I was like, oh yeah, use this app build pack. Oh, it only works on the Heroku builder. So it seems like it's not unsolvable. Like I think the build pack IDs would let you be like, as a builder maintainer, you can be like, oh, I'll add this hook to support that build pack. But I don't know, I think that's potentially a risk.
The idea is that anything hooks can do, you could do to your base images instead. And so this shouldn't perpetuate anything that isn't already perpetuated by having people have the ability to use different base images, if that makes sense. And I'd imagine that you could create a tool that pre-applies hooks, right? So like your build is slow because it uses these hooks. You run some tool on your builder and it outputs a builder with all the hooks pre-applied. And now you have a faster builder, right? Because all it's doing is automating the process of creating a more narrowly scoped builder for a set of build packs. Any outcome of this, while I agree it makes it easier to customize builders in some ways, right? So you could certainly perpetuate that, right? Anything you can do using the hooks API, you can do without hooks and without making any changes to the build packs at all. Because there's no feed, like you're not feeding like the detection output of the build packs anywhere, anything like that. They're, as a builder author, you could say, I'm going to put these build packs for this app here and run these commands ahead of time, right? Or you could say, I'm going to put hooks here and it'll slow down the build process, but that stuff will happen dynamically before build. That was a big goal for me, at least.
So channeling Charles, who's been chatting us up in Slack, I think one of the drawbacks of Dockerfile over like LLB JSON or other mechanisms is inability to write tests. Although like Dockerfile isn't a testable thing in terms of like writing unit tests for it. I know he's brought that up. But I don't know, I would argue that like the job of any of this stuff is like massive side effects that are difficult to test anyways. And I think like, I think your testing mechanism is like run the Docker file or whatever the thing is. And if you're going to test it all, it's got to actually do the thing.
I agree. If there's a lot of pushback that we need to just support something similar, I'd be happy to say, add a script format. It's just a Docker.
Yeah, that's where I was going to go next. Yeah.
Wouldn't be too bad.
So if I run the same build more than once, would it run the hooks more than once, or would the hooks already have been applied from the first build?
I think it'll use Dockerfile caching. And so if you use this build ID somewhere, it'll start rebuilding from there. Because it supports app specified Docker files and the app directory could change, right? Like, because you can read the app directory, there are some you kind of need to reapply it, but there is the Dockerfile caching, right? If nothing changes, and it should be very fast. So the idea is just rely on what's coming upstream.
Would the context for both the hooks and the doc context itself be the app directory? So I get the context for the hooks is the app directory. For the Docker build itself, is that also the app directory?
Context for, no, the app directory isn't copied into the Dockerfile context. The hooks execute in the context of the app directory, but the Docker files don't execute with the app directory as their context in the current proposal. Yeah, we could do that, but I don't know.
So what is the context? I think they require some context, right? Like it's just
empty directory. Tarball sent to Docker daemon is empty. One idea I thought about, an alternative down here, is like we could use directories here instead of the names, and then these could be the context of the Docker file if you wanted to. I wouldn't be too opposed to that. It'd be a little weird because we'd be feeding other Docker file into that.
The reason I ask is, let's say in the builder itself, if okay. I'm just wondering how you. Oh yeah.
I got to drop because we're a couple minutes over. I'm late to something. If people have more comments, please leave them on the thing. Glad to hear nobody is extremely freaked out by the idea and thinks it can never work, at least probably. I was, wasn't sure. Thanks. Peace.